Hi everybody, this is Chris from Caltech Science Olympiad Planning Team, and today we'll be going over how to typeset maths and chemistry inside the Science Olympiad online testing platform Scilympiad. So let's dive right in. First, we're going to create a new question. We'll set it to be a true-false question just for simplicity. Now, if we type some text, for example hello, into our text box, and then load our test in the test preview view, we see that it just comes out as hello. There's no special formatting attached to it at all. And so in order to activate the special maths formatting mode, we're going to have to use a different kind of syntax that tells MathJax that we want maths instead of text. And the way that you can do that is by using a $sign and an opening brace, and then a space, and then a closing brace and a $sign. Now that we've told MathJax that we want maths mode, we can put our maths in between these two brackets to have it typeset specially. And the first thing that we can do in this mode is to do superscripts and subscripts. So let's do subscripts first. Say we want to do 2 subscript 1. We can do that by first typing a 2, and then an underscore, and then a 1. So what this means is the number before the underscore is the number that we want our subscript to be attached to, and the number that comes after the underscore is the actual subscript. And now when we load our test in the test preview window, we see that we have exactly what we wanted, 2 to the subscript of 1. Superscripts are extremely similar. In fact, we type them with the exact same syntax, and both sides mean the exact same thing, except we just use a caret instead of an underscore. So to do 3 to the power of 1, all we have to do is type 3, a caret, and a 1. When we save, and then load the test again in the preview, we'll see that's exactly what we have, a 3 to the power of 1. Now let's say we want to type a bigger subscript. For example, maybe we want 3 to the power of 10. If we try and type that directly, we'll notice that when we just type 3 caret 10, and then go and render it in our test preview, it actually comes out not as we would expect. We have a 3 to the power of 1 and then a 0 instead of 3 to the power of 10. And that's because MathJax expects only a single number after the caret. And to do multiple numbers, what we have to do is put it inside 2 curly braces to tell MathJax that we want both these numbers to stay together when we apply the caret symbol. Putting these numbers together makes them a group, which means that whatever styling we apply to them, whether that be fractions, subscripts, superscripts, square roots, anything like that, they'll always be treated together and will all go together into the symbol that we apply. When we save and go to the test preview, we see this is what we actually wanted, 3 to the power of 10. In addition to doing powers, we also probably want to do square roots, and the way we can do that is by using a command, the sqrt command, which stands for square root. And that can be invoked by simply typing backslash and then sqrt, an opening curly brace, a closing curly brace, and in between the 2 curly braces we put what we want to be square rooted. And in this case we'll just use 3 again as the example. Saving and reloading our test in the test preview window, we'll see that we have square root of 3 as expected. Perhaps we want to take the cube root, or maybe the 4th root of this number instead of taking the square root. We can do that simply by adding 2 square brackets right before our curly brackets and then putting the number inside those square brackets. In this case, say we want the cubed root of 3, so inside our 2 square brackets we'll just put the number 3. And when we save and reload in the test preview window, we'll see this is exactly what we get, the cube root of 3. In addition to doing roots and powers, we can also do trigonometric functions, and the way we can do that is by using the same syntax as the square root syntax, but replacing the sqrt with the trigonometric function we want. Trigonometric functions in MathJax are all named after the standard mathematical abbreviations for those functions. If we want cosine of pi, for example, the MathJax command to produce that is just \cos. When we reload, we see we have cosine of pi. Let's talk about typesetting Greek letters like alpha and beta. To do so, all you need is a backslash and then the name of the letter that you want. For example, for an alpha, all you have to do is backslash and then alpha. For beta, backslash beta, for gamma, backslash gamma, and so on. We'll link to a symbol table in the description that provides MathJax commands for all of the Greek letters. So don't worry if you don't have them all memorized. By default, MathJax produces a lowercase version of all of the Greek symbols. For the Greek symbols for where there is a capital letter, you can produce it just by capitalizing the first letter of a command. For example, to typeset a capital delta, all you have to do is backslash delta with a capital D. A lot about how to typeset individual symbols, but now let's shift our focus to putting these individual symbols together. The first thing we're going to focus on is fractions. Suppose we want to typeset 1/2, but we want it to look nice, because we notice that when we type 1/2 directly with a slash, it comes out as it looks in the editor. It's just a 1 and a slash and a 2, which doesn't really look nice. We want it to be on top of each other like it is when we write it on paper. The way we can do that is by using the fraction environment. Fractions can be typeset by using the \frac command to start fraction mode, and then adding two groups of curly braces, where the first one is the numerator and the second one is the denominator. To produce our 1/2, all we have to do is put the 1 in the numerator part and the 2 in the denominator part, and reloading our test preview shows that we now have 1/2 with the 1 above and the 2 below. We can also typeset a variety of comparison operators, for example equals, not equal, and greater than or equal to. So let's go back to our fraction example, and suppose we want to compare the 1/2 to 1/3. We can produce the operators equals and not equals by using our keyboard's equal sign and the command \neq respectively. The greater than and less than signs are the same as the ones on your keyboard. The greater than or equal to and less than or equal to symbols can be produced by the commands \geq and \leq respectively. Saving and reloading our test, we see that these commands give the symbols that are expected. In some cases, you may need a matrix, and typesetting matrices can be done by using the begin bmatrix command. This uses the syntax \begin, an opening brace, bmatrix, a closing brace, and then a \end, and then an opening brace, bmatrix, and a closing bracket. Like the $sign bracket that starts the maths mode, this syntax tells MathJax that we want a special array mode. Within this array mode, you separate your different row elements with double backslashes and your column elements by an ampersand. So in this case, we've created a 2x3 matrix consisting of the numbers 1, 2, 3, 4, 5, and 6. Reloading shows this is exactly what we wanted. We produced a matrix with 2 rows and 3 columns. The matrix mode can contain any number of rows and columns that will fit in the text box. If you want a matrix that uses parentheses instead of brackets, simply replace the B in B matrix with a P. That's all for the basic maths mode. Now let's move on to doing chemistry. In order to define a chemistry environment, all you have to do is insert a \CE in between the first $sign and first curly brace, as follows. This informs MathJax we want to now typeset chemistry, and MathJax turns on a couple of different settings that makes our life easier when typesetting chemistry. Let's suppose we want to write the chemical formula for water, H2O. We can actually just write the formula H2O directly. We don't actually need the subscript symbol underscore. We notice that when we reload our test with the saves, it actually just automatically subscripts the number for us. Creating ions and isotopes uses the same subscript and superscript syntax as before. As we see here, we can use a double bracket and a caret to do a 4 minus on the O. We can also use a caret and a bracket and an underscore in a bracket to do the 150 before the U as shown. Saving and previewing gives the expected results. Finally, let's talk about yield arrows. In the chemistry mode, we can use all kinds of different arrows. As an example, let's say we want to type the equation H plus O minus equals H2O. We can do that simply by typing that out, but where we put the arrow, we just use a dash and then a greater than sign. And that will produce an arrow in the rightwards direction. Once we save and preview, we see that this is exactly what we get. H plus O minus, right arrow, H2O. The arrows in the chemistry mode aren't just limited to the forward direction. They can also go backwards or be bidirectional and imbalanced. To typeset those, let's take a look at how to typeset those. For a reversed arrow, all we have to do is use a less than sign on the left instead of a greater than sign on the right. A bidirectional arrow is an equal sign with both a greater than sign on the right side and a less than sign on the left side. An imbalanced bidirectional arrow can be drawn by using an equal sign, a less than sign on the left, a greater sign on the right, and then an additional greater than or less than sign, depending on the direction that the arrow should favor. Our equation should favor the right, so we use a double greater than sign on the right. Reloading the test, we see these are the expected results. In order to attach text to the arrows, we can use square brackets. Let's change our arrow back to the forwards only arrow. Now suppose we wanted the text hello to be on top of this arrow. We can do that by placing a square bracket on the right side of the arrow, then our text, and then a closing square bracket. When we save and reload, we'll see that our arrow now has the text hello above it. To display chemical formulas above the arrows, all we have to do is add a capital C before the square brackets and then type our chemical formula inside the square brackets. After reloading, we see we have an H2O properly formatted on top of the arrow. To have a formula on the bottom of the arrow, all we have to do is add a second square bracket, and then put our formula inside the second square bracket. In this case, we've used H3O, and now we see we have an H2O above and an H3O below.